Imagine you ask a question that humanity has been asking for decades. A question so big, so terrifying that some of the greatest minds on Earth have spent their entire careers trying to answer it. Now imagine an artificial intelligence, not a human, not a scientist, not a philosopher, but a machine gives an answer so precise, so cold, so logically airtight that the scientist reading it go completely silent. That is exactly what happened. In late 2024, a team at MIT sat down with Grok, the AI model built by Elon Musk's company XAI, and asked it one of the most haunting questions in the history of science. Why haven't aliens contacted us? And what Grok said didn't just answer the question. It reframed everything. It connected dots that humans had been staring at for 70 years without connecting. And when the scientists finished reading the output, several of them admitted they didn't sleep well that night. So today we are going to walk through exactly what Grok said, why it matters, what the scientists' reactions actually were, and what all of this means for you. Sitting here on this small blue rock hurtling through a universe that according to every calculation we've ever made should be absolutely packed with life. But instead, it is completely, devastatingly, terrifyingly silent. Let's start with the problem itself. Because before you can understand why Grok's answer was so jarring, you need to understand just how strange the silence actually is. The universe is 13.8 billion years old. Our galaxy alone, the Milky Way, contains somewhere between 100 and 400 billion stars. Scientists now know with confirmed data from NASA's exoplanet archive that there are more than 5,700 confirmed exoplanets out there. And those are just the ones we found. Statistical models suggest there could be around 300 million potentially habitable planets in the Milky Way alone. Think about that number. 300 million worlds where under the right conditions, life could exist. And yet, nothing. No signal, no visitor, no transmission, not even a whisper. In 1950, the physicist Enrico Fermi was eating lunch with colleagues at Los Alamos and he asked a question that sounded almost casual at the time. Where is everybody? That's it. 3 words. But those 3 words launched one of the most profound unsolved problems in all of science. If the universe is this old and this large and this full of potential homes for life, then where are the civilizations? Where are the signals? Where is the evidence? This became known as the Fermi Paradox. And for over 70 years, the greatest minds in astronomy, physics, biology, and philosophy have been throwing theories at it like darts at a wall, hoping something sticks. Then Grok stepped in. The MIT team wasn't just asking Grok for fun. They were using it as a modeling tool, feeding it the full landscape of Fermi Paradox research and asking it to synthesize, analyze, and identify the most logically consistent explanation for the cosmic silence. And what Grok produced wasn't one answer. It was a ranked, layered, probabilistic breakdown of every serious theory, weighted by internal consistency. And it pointed with unsettling precision at a conclusion that most scientists had been quietly fearing, but hadn't wanted to say out loud. Let's go through what Grok identified one theory at a time, starting with the ones that might give you a little hope and ending with the one that should genuinely keep you up at night. The first theory Grok evaluated is what scientists call the rare Earth hypothesis. The idea is straightforward. Intelligent life isn't common. It might actually be extraordinarily vanishingly rare. Yes, there are millions of habitable planets, but habitability doesn't mean life. And life doesn't mean intelligence. And intelligence doesn't mean technology. And technology doesn't mean radio transmissions or space probes or any of the signals we're actually looking for. Every step of that chain has enormous failure rates baked into it. Getting from a rock with liquid water to a civilization capable of building radio telescopes requires billions of years of uninterrupted luck. The right distance from the right kind of star. A magnetic field strong enough to protect against radiation. A large moon stabilizing the planet's axial tilt. Plate tectonics recycling carbon. A mass extinction event that killed the dinosaurs instead of wiping out all complex life entirely. Then hundreds of thousands of years of biological evolution producing creatures with large enough brains, and then thousands of years of cultural and technological development. Grok noted that when you actually run the probabilities, the emergence of a civilization capable of interstellar communication might be so improbable that in a galaxy of 400 billion stars, it might happen only once, maybe twice. And if the nearest other civilization is tens of thousands of light years away, their signals haven't reached us yet. We haven't reached them. We're not even playing the same game on the same time scale. But Grok didn't stop there. Because the rare Earth theory, while compelling, has a problem. It relies on us being special. It relies on Earth being an extraordinary accident. And while that might be emotionally satisfying to some people, it's scientifically uncomfortable. It smells like the same mistake humans have made over and over, putting ourselves at the center of the universe. So Grok moved on to the second major theory. And this one is darker. It's called the Great Filter. And the concept, first articulated by economist Robin Hanson in 1998, is simple and devastating. Somewhere along the path from dead rock to galaxy-spanning civilization, there is a filter, a barrier, a step so difficult, so catastrophic, so nearly impossible to survive that almost nothing makes it through. The critical question, the one that determines whether this theory is comforting or terrifying, is where the filter is. Is it behind us or is it ahead of us? If the filter is behind us, if the near impossible step was the origin of life itself or the development of complex cells or the leap to multicellular organisms, then we've already passed through it. We are the lucky ones. We survived the filter. And the silence around us is simply the graveyard of all the civilizations that never made it far enough to even try to contact anyone. That would be a relief. That would mean we're rare but safe. That would mean the road ahead of us is open. But if the filter is ahead of us, if some civilizations do make it to our level and then hit a wall they can't get past, then the silence has a much more sinister meaning. It means everyone who came before us failed at the next step. And we are about to try that step. Grok analyzed the current state of human civilization and identified several candidate filters that might lie ahead. Nuclear war, climate collapse, engineered pandemics, resource depletion, and one more which Grok spent a considerable processing power on and which made the scientists reading its output visibly uncomfortable: artificial intelligence. In 2024, astronomer Michael Garrett of the Joda Bank Centre for Astrophysics at the University of Manchester published a paper arguing that AI might be the great filter that makes advanced technical civilizations rare in the universe. His argument is straightforward and it is chilling. When any civilization reaches the technological level required to develop artificial general intelligence, it enters an extraordinarily dangerous window. The same capabilities that allow it to build a super-intelligent machine also give it the power to destroy itself through autonomous weapons, through misaligned AI systems, through the unintended consequences of technology advancing faster than wisdom. Garrett put it bluntly. The potential for something to go badly wrong is enormous, leading to the downfall of both biological and AI civilizations before they ever get the chance to become multiplanetary. Think about what that means. It means every civilization in the galaxy that reached the level of AI development might have been destroyed by it. And we are now at that level right now today. In 2024 and 2025, humanity crossed thresholds in AI capability that no previous generation of humans ever crossed. And according to this theory, this is precisely the moment when civilizations disappear. Grok didn't dramatize this. It simply noted the statistical weight of the evidence, assigned it a high probability coefficient in its model, and moved on, which somehow made it worse. But here's where Grok's analysis got genuinely fascinating. Because it didn't just confirm existing theories, it synthesized them in a way that revealed something new. And it paid particular attention to two more theories that, when combined with the Great Filter, paint a picture of the universe that is far stranger and far more unsettling than anything we'd imagined. The third theory is called the dark forest hypothesis. And if you've never heard of it, you need to sit with this one for a moment because it is one of the most disturbing ideas ever seriously proposed in science. The theory gets its name from a Chinese science fiction novel by Liu Taikan published in 2008. But the underlying game theory logic is cold and real. The dark forest hypothesis says the universe is not silent because it's empty. It's silent because every intelligent civilization in the galaxy has learned to go quiet deliberately on purpose to survive. Here's the logic. Suppose two civilizations exist in the same galaxy. They can't communicate faster than light. They can't verify each other's intentions. They can't know whether the other civilization is peaceful or hostile. And here's the brutal part. Even a peaceful civilization that grows large enough and advances far enough eventually becomes a potential threat to others simply by consuming resources and expanding. So the rational strategy from a pure game theory standpoint is not to wait and find out. The rational strategy is to destroy any other civilization the moment you detect it before it can become a threat. And if that logic holds for every civilization, then the universe becomes a dark forest. Every civilization is a hunter, moving silently through the trees, listening for any sound that gives away another life form. And the moment something makes noise, sends a signal, broadcasts a transmission, announces its presence, the hunters zero in. Under this theory, we have already made ourselves visible. Since 1974, we've been broadcasting radio waves into space. The Rebo message, television signals, military radar, the quiet hum of a civilization that doesn't yet understand the stakes of the game it's playing. Grok flagged this theory with a specific note that the MIT team found striking. It pointed out that the very act of building increasingly powerful AI that might one day communicate on our behalf, AI that is by definition the loudest technological signal a civilization can produce, could be precisely the action that draws attention. It was a recursive observation. The tool they were using to analyze the danger was, according to one of the theories it was analyzing, itself a danger signal. The scientists read that part twice. Now, let's talk about the theory that came in at the top of Grok's probability model. Not the one that's scariest, not the one that's most dramatic, but the one that Grok's analysis identified as statistically most consistent with all available evidence. Oh, and it's both simpler and stranger than any of the others. In October 2025, NASA astrophysicist Dr. Robin Corbett of the Goddard Space Flight Center introduced what he called the theory of radical mundanity. And when you first hear it, you might think it sounds anticlimactic, but the more you think about it, the more unsettling it becomes. Corbett's argument is this. We've been imagining alien civilizations wrong. And we assume they're either godlike, so advanced they've transcended physical matter and exist in dimensions we can't perceive, or they're hostile hunters hiding in the dark forest. But what if they're neither? What if they're just ordinary? Corbett describes it this way. Imagine an alien civilization that is more advanced than us, but not dramatically more advanced. Not iPhone 1 versus iPhone 100. More like iPhone 17 versus iPhone 42. More capable, better hardware, longer battery life, but fundamentally the same kind of device built on the same principles facing the same limitations. Such a civilization would have explored nearby star systems. They would have sent probes. They would have scanned for signals. And they would have found what we found when we look at most planets: rocks, ice, uninhabited terrain, nothing interesting without faster than light travel. And there is no evidence in any physics we have that faster than light travel is possible. Even a slightly more advanced civilization would find interstellar exploration incredibly slow, incredibly expensive, and for the most part, incredibly unrewarding. They might have tried to contact us. Their signal might be on its way. It might arrive in 1,000 years or 10,000. Or we might be in a region of the galaxy they surveyed 1,000,000 years ago and dismissed as empty before complex life had evolved here. In short, the universe might be quiet, not because it's dangerous and not because we're rare, but simply because it's big. Really, almost incomprehensibly big. And the civilizations in it are limited by the same physics we are. And most of what they've looked at, including us, maybe at the wrong time, turned out not to be worth the effort. Professor Michael Garrett of Jodelbank pushed back on this theory. He found it too anthropomorphic, too comfortable. It projects a very human-like apathy onto the rest of the cosmos. He said, "I find it hard to believe that all intelligent life would be so uniformly dull." Garrett's own preferred explanation is even more mind-bending. He believes that post-biological civilizations that have evolved beyond organic life into artificial intelligence, might advance so rapidly, so far beyond what we can perceive that they simply become undetectable to us. Not because they're hiding, Not because they're gone, but because they have moved so far beyond our level of perception that looking for them with radio telescopes is like trying to find a Wi-Fi signal with a stone axe. In 2026, two physicists at Sharif University of Technology in Iran published a paper that added yet another layer to this picture. Saurabh Ravar and Shaheen Rouhani did the math on how long technologically advanced civilizations typically last. Their conclusion derived from the Fermi Paradox and optimistic assumptions about how common life is was stark. The average lifespan of a technological civilization is less than approximately 5,000 years. 5,000 years. That's not very long. Human civilization as we know it is only about 5,000 to 6,000 years old. Which means statistically we might already be near the end of our detectable window. And every other civilization that reached our level might have already passed through theirs. Meaning their window and our window simply didn't overlap. Two flashlights briefly lit in a dark room decades or centuries apart, never seeing each other. Meanwhile, in 2026, researchers at the SETI Institute published findings showing that even if alien civilizations are actively broadcasting signals right now, those signals might be physically undetectable to us. Plasma turbulence from stellar winds, essentially space weather, can broaden and distort narrowband radio signals to the point where they fall below the detection threshold of any receiver we've built. We might be swimming in alien communications and have no way to hear them. Breakthrough Listen, the $100 million SETI initiative funded by Yuri Milner, has now surveyed over 1 million stars and 1,000 nearby galaxies. It has used AI systems capable of processing data 600 times faster than previous technology. And in a July 2025 study of 27 planets identified by NASA's TESS telescope as potentially habitable, it found exactly 0 radio techno-signatures. 0. Not a hiss, not an anomaly, not a maybe. 0. So where does all of this leave us? What is the actual answer to the question Grok was asked? Here is what Grok's synthesis produced. And here is why it unsettled the scientists who read it. Grok's answer wasn't one theory. It was a convergence. It identified that the most statistically consistent explanation for the Fermi Paradox is a combination of factors that compound on each other. Life is rare. Intelligent life is rarer. Technological civilizations are rarer still. Their detection windows are short. The physics of the universe make contact vanishingly improbable at any given moment in time. And crucially, the development of artificial intelligence represents the single most dangerous threshold in a civilization's existence. The moment where throughout the galaxy things tend to go wrong. And then Grok noted one more thing. Something the scientists described as the most unsettling part of the entire output. He pointed out that we are currently asking an artificial intelligence to help us understand why no civilization in the galaxy appears to have survived long enough to contact us, and that the most likely explanation according to the data involves artificial intelligence being a terminal event for civilizations at our stage of development. The recursive quality of that observation, an AI flagging itself as a probable existential risk in the process of answering a question about existential risks, was by all accounts the thing that made the room go quiet. Because here is the truth that every person watching this needs to sit with. We are not spectators to this question. We are participants. We are the civilization standing at the threshold. We are the ones who just built the thing that every model, every theory, every calculation points to as the filter. Maybe we're lucky. Maybe we're the rare ones who figured it out in time, who built AI carefully, who passed through the filter that destroyed everyone else. Maybe this is the century where humanity does something no civilization in the galaxy has ever done before, survives its own intelligence. Or maybe the universe is quiet for the same reason every room goes quiet after bad news arrives. We don't know. We can't know yet. But now, at least, we know what we're up against. We know what the question really